Let's talk quadratics. So I know I asked some of you guys to work out some things, and I just want to run through a few of these. And because I've taught for only 3 or 4 months, I've started becoming a little bit more aware where certain errors have taken place. So on the side of our worksheet of 1 through 10, is there one that sticks out to you that you're just kind of goofed on? Some of them have all the A, B, and C values. Some of them don't have the A, B, and C value. If they don't have the A, B, C value, what value do you put in for A, B, or C if it's missing? 0. Okay, if it's missing, if it's not there, if your squared value, the lead coefficient is not there, then you put 0 in. If your B value is not there, which is x, what's tagged to the x, you put a 0. If your C value is not there, that's your constant. If that's not there, you put 0 in. So, any that are popping out to you? This is the page I handed out the other day, sheet 5B. Gabe, did you have any? We were working on a few this morning that you... 14, all right, let's go there. And you can jot down notes if you see fit. I mean, this is a part of Algebra 1 that we will focus quite a bit with. Oh, and then there is a Schoology 10 that is due. There was one problem. I just had to go back through. I realized it wasn't. It said, it's now back. It's now back. It'll work. It was like, use the quadratic formula to solve this, and then there was four answers.
It's just guess.
I bet it's A. All right. So they're using n rather than using x, which is okay. I'm always all right if you decide, hey, I want to change everything back to x. That's fine. But there's one thing this problem is not. It's not set up to. It's not equal to 0. So if it's not equal to 0, we need to move things. Do you agree? So we can choose one of two things. I can either move the negative 2n. I get the hiccups right now. Excuse me. You can move negative 2n squared over by adding negative 2n squared to both sides. Or you can move the negative 4 over by adding it to both sides. You can move the 4n over by subtracting 4n from both sides. And you know what? The answer is going to be the same regardless. How can that be? Sometimes things will be negative positive. How the problem works is if you do have negatives, by me moving all of this over here, the negatives take care of themselves in the same way as if I just move this over here. So, Gabe, your problem. Which one do you want me to do? Do you want me to add 2n squared to both sides, or would you like me to add 4 and subtract 4n from both sides? Add 2n? And sometimes this puts a little panic in people going, but the 0 is on the left side now. So, I'm going to put this in descending order. I flip-flopped this order over. I put the 4n first, and then I had the minus 4 there. So from here, I know that I can go A is equal to 2, B is equal to 4, and C is equal to negative 4. And I know that X is equal to negative B plus or minus squared B squared minus 4 AC over 2A. I know that's there.
What does that mean? I don't know the
Pop goes the weasel. All right. I found that I heard someone say that there's one that goes with row, row, row your boat, but I haven't figured that one out yet, so I'm not sure which song you need. All right, let's plug things in. All right, so I have my A, B, and C. I'm going to plug into this. Okay, so I have wherever I have blanks or parentheses, I'm going to plug in. So X is equal to negative B. My B value is this. Plus or minus square root. B squared minus 4AC. A is 2. C is negative 4. All over 2A. Do you agree how I plugged that in? Okay, so errors that might take place on this problem. The nice thing is our B value, as we have it set up right now, is a positive 4. Okay? So a lot of times, if this is a negative, you trust your calculator too much. So let me move down. Okay, so I have negative 4 plus or minus 4 squared. That's 16. And then I have negative 4 times 2, that's negative 8. And then I have negative 8 times negative 4, which is positive 32. Sweet. All over 4. Does this seem to be okay so far?
Yeah.
So let's put together, let's add 16 and 32 together. So I'm going to bring this way. So I got negative 4 plus or minus square root 48 all over 4. Now we have to think, can I break square root 48 down? Okay, square root 48. So my perfect squares, I know I have 4, I have 9, I have 16, I have 25, I have 36, I have 49. So 4 does indeed work, but it's 4 times 12. So 4 is not our biggest perfect square that works. 16 works. Okay? So let's break this down to 16 times 3. 16 is our largest perfect square that goes into 48. I know this is break down to this, which then breaks down to this. So I have negative 4 plus or minus. I'm going to replace root 48 with 4 root 3. And the whole thing is all over 4. There's 3 places I can reduce on this problem. I cannot reduce inside of the radical ever if I have something outside. Okay, so meaning the 4 in the denominator, even if it went into this 3, which it doesn't regardless, I can't go outside of a radical to inside of a radical to reduce. So from there, I can say, all right, well, looks like 4 goes into itself once, 4 goes into itself once, 4 goes into itself once. So the answer to this problem is negative 1 plus or minus 1 square root 3. 1 square root 3 is the same thing as square root 3. How many answers is that? There's 2. Because you have negative 1 plus square root 3 and you have negative 1 minus square root 3. So we use the plus minus to shorten what our answer would be. Someone asked a few years ago in another school, could I have 1 plus square root 3 and then 1 minus square root 3 as the whole answer? Absolutely. You have to use the plus minus as a shortcut. It's up to you. So there's our first problem. What else should we take a look at on this worksheet? Anything that's sticking out to y'all? Yeah.
I'm just kind of confused how you knew that like 16 and 3 was going to be the one that you used.
Okay, so let's take square root 48. So let's go a slightly different approach, because that's a real thing that I get it. It's like I can't see it right away. So let's do our prime factorization. Let's take ourselves back to elementary school, which means we're going to create a factored tree. Do you remember that?
Yeah.
And you're like, then you learn like all these weird rules of things, and you're like, I'll never remember this. You know, like, you know that 16 goes into it. If you sum all the numbers together, square them, and then subtract 11, 16 goes into it. That's hard. I wouldn't do it that way. All right, so, exactly. So let's break 48 down. So I know the smallest number that goes into it would be 2. Yes, 1 does go into it, but it doesn't help us. So 2 times 24 is 48. So I'm going to put a square around 2 because I can't break 2 down any further. Is that okay? So 2 times 24 and 2 times whatever else will give us our answer. So then let's break 24 down a little further. I know that 2 and 12 work. So I'm going to put a square around that 2. So I know that now 2 times 2 times 12 is 48. Do you agree with that? So let's keep breaking 12 down a little bit further. I know 2 goes into that as well, so that's 2 times 6. So I'm going to put a square around that. Can't break that 2 down. So now I know that 2 times 2 times 2 times 6 is 48. Right? And then I can break 6 down a little bit more. I can break that down into 2 and 3. So 2 times 2 times 2 times 2 times 3. So let's do this. This is a different approach. Would you agree with that? Make sense? If you're going to do the square root of something, you might remember this. There's a little 2 right here. We don't put that 2 there because we're lazy. Okay? There are third roots, fourth roots, fifth roots, sixth roots, so on and so forth. So what this basically means is I'm looking for pairs, and each pair is a perfect square. Because think about this. 2 times 2 is 4, right? 2 times 2 is 4. 4 times 4 is 16. So, square root of that is 2. Square root of that is 2. Square root of that, we don't know. 2 times 2 is 4. So that's where this could have been 16, because 2 times 2 is 4 times 2 is 8 times 2 is 16. So that's a way to approach it as well. It's okay that you don't see, oh my gosh, what's the biggest perfect square? Especially when you start talking like bigger numbers, like 36. I don't know 36 goes in that. Are you kidding? Best I can do is 9. So you can break down as prime factorization if you want. And then what you're looking for is pairs of numbers. And a pair of numbers, if you take a square root of a pair of numbers, the single comes out. Because the pair of 2's is 4. Square root of 4 is 2. That's where that came from. Square root of 4 is 2. That's where that came from. So this could have been this. So the square root of 16 is 4.
So like always when it's like, since the 3 wasn't like root, that always goes on like the inside, and
Yeah.
this root goes on the outside.
So if you don't have a pair of something, it can't come out as a square root. Okay, and it's just a different way. That's a great question.
And then if the 2's were 3's, would it just be like 3 times 3?
So let's do this. Let's say we broke something down and we had this. I wanted to keep it as a prime number. Let's say we had something like that. So I have a pair here. I have a pair here. And I have a pair here. Do you agree? So this would give me 4. Square root of 4 is 2. This would give me 9. Square root of 9 is 3. This is 25. Square root of 25 is 5. What do I have left inside? I have a 2 and I have a 7. So I'm going to multiply those back together. So then I have 2 times 3, which is 6. 6 times 5 is 30. So 30 square root 14 would be how something like this would break down if you broke it down to its prime components. Does that make sense?
Yeah.
Cool. Other questions from the worksheet? What do we come across on that? Anything else? 19? Yeah, a little bit. Okay, 19 is going to be a little bit similar. We're using m's. So I have m squared is equal to 4m minus 4. So Reese, on this problem, I could choose to do it one of two ways. I could subtract m squared from both sides, or I could subtract 4m and bring it over, and I could add 4 and bring it over. So it's your choice how you'd want to do it. And again, where kids don't like it is when you have 0 equals. So a lot of people want the equals 0.
Yeah.
It's your choice how you want to do it.
Oh, we can move the M2 to the other side.
M squared, move it over? All right, so I'll move it over. So I'm going to subtract this from both sides. So that gives me 0 is equal to negative m squared plus 4m m minus 4. Okay? So our a value is negative 1, our b value is 4, my c value is negative 4. You okay about that?
Yes.
Everyone with me on this?
Yeah, baby.
And then we know that x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. All right? Anything going to stick out for us? We note that we have a few negatives, so we can't just say, no, we're not going to use them. So x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Okay? X equals negative b. Negative b plus or minus square root b squared minus 4ac all over 2a. There's a whole bunch of negatives up there. A whole bunch of places people can make errors. Because arithmetic is the hardest part of math. The stuff from elementary school.
Math is the hardest part of math?
So
Arithmetic.
Math
If
is
I'm
the hardest part
correct.
of math?
Math is the hard part of math. Yeah.
if I'm correct, doesn't that mean that the
No.
negative to a 4 and the negative 1 will combine together is going to equal out to positive 4?
Okay, so let's walk through it real quick. So I have negative 4. That comes down, yes?
Yes.
B squared. So 4 squared, 16. Negative 4 times 1. Positive 4, right? Positive 4 times negative 4.
Then that's going to be
Negative 16, right?
negative 16.
All over negative 2. Okay? What happens here? Cancels. It's what? 0. What's the square root of 0?
0.
If I add and subtract 0 from something, I get
0.
0. So this becomes -4 over -2. That reduces to what? +2. There's my answer. Only one answer on that one because underneath the radical, underneath the square root sign, it became 0. That later in life is called the discriminant. Underneath the radical, so b squared minus 4ac is called the discriminant. And if the discriminant 0, that leaves us one answer. So guys and girls, what I'd like you to do, first and foremost, take care of one another. Because math is just math. And taking care of one another is life. Right? So would you please finish this worksheet 5B? Make sure it's done. I will check it off tomorrow for points.
What page?
It's the one I had given you the other day.
Oh.
Oh.
I'm not sure one of those is
Okay. So if you have like this, I could also have it written like this.
Okay, so I did it. Okay.
So that and this.
So you don't have to subtract it, it'll give you the same.
Same exact answer. The reason why is A on this one is 1, B is equal to -3, C is equal to -4. On this one, A is equal to -1, B is equal to 3, C is equal to 4. So notice, positive, negative, 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 positive, positive. Because of how the quadratic formula is set up, this is going to result in the exact same answer as this. Is that all right?
Yeah.
Perfect.